Hey, what's going on everyone? Vega here for SerpentX Tech, and in our previous video we unpacked this NerdQAxe++, able to hit the advertised 4.8 terahash at around 80-ish watts. It does say 72 on the website. I'm sitting more around 80, but I do have a secondary fan plugged in, as you can see from that connection. And I just want to go through and see what we can benchmark and push this thing to. It does have 4 BM1370 chips, and it's sitting around 18 watts per terahash. So what can we efficiently get this thing pushed to? While on the website it does say 72 watts, we're sitting around 83, 84 watts right now. So let's go switch over to the computer, run the benchmarks, and see what the before and after results are on this NerdQAxe++. All right, so here we are on the computer. I'm just gonna go into my command prompt, basically to open up WSL or Windows Subsystem Linux. I showed you how to do this in a previous video. I'll link it down in the description. But I just type in WSL. Now I'm gonna be in my Linux distribution. I do need to get Docker Desktop up and running, so I'm just gonna go ahead and run that because we do need that because we're using RetroMike's configuration, right? It's a Docker image called the Bitaxe bench. Actually, I don't think it's RetroMike's image, but I think RetroMike did retrofit it, for lack of a better word, for this particular one. And I already have the command here, which is docker run --rm Romeo Mary, the RetroMike / the Bitaxe benchmark, and then we need to put in the IP address of the machine, and then the voltage and frequency. V is for voltage, F is for frequency. We obviously want to take into account what we're currently seeing. We're hitting the advertised 4.8 terahash right now, and the clocks are basically 600 on the core, and the voltage is 1150. So after I run the command, you can see it actually taking effect. Again, it's not going to show in the window, but you can see it taking effect on the miner. But there's a problem that we're going to run into. However, I'm going to let the error pop up and show you what it is. But while RetroMike's Docker format is super easy to use for your normal Bitaxes and NerdAxes, because this is the NerdQAxe, there's a big difference, and we'll show you what that difference is once the error shows up. So here's the error. You can see that the clocks, if you look, it went back from 400 to 600, and the error is that the input voltage is above the maximum allowed. It's thinking it's a Bitaxe, and the Bitaxe is 5 volts. The NerdQAxe and the NerdQAxe++ requires 12 volts, so there's some adjustments we need to do. So I'm just going to close out this window, open up a new one, a regular control prompt window. And what we're going to do is going to run this command. I'm going to have the link down in the description, but basically rebuilding Mr. V777's Bitaxe hash rate benchmark. So RetroMike just made it easier with the Docker. This time we're just going to build it from scratch. So we're going to git clone and then the repo. It's going to download that to our user folder. So we're going to go to the user folder and look for this guy, refresh, and here it is. And if we open this up, if I right click open with Visual Studio, you will see in this section here that we have maximum input voltage 5500, which is what the error said. So we need to play around with this very carefully, knowing that this benchmark will push your device beyond its limitations and you are at risk of bricking your device. So only do this under your own discretion. Power, first of all, 40 watts is not enough. So we're definitely going to want to push that. Right now, the device, I think, is sitting around 84. So yeah, 84 watts. So let's put 100 here for right now. And then input voltage, I don't know how far I want to go, but let's say 12. I don't think 12,500 is good. So I'm probably going to do 12,200 or 12,250, something like that. Minimum input voltage, we're just going to put maybe, again, this is I got to be very careful here. So 11.8 volts to 12.2 volts is our minimum and our maximums. We could play around with our VRM max temp. We could play around with our max CPU temp. We can find this information by going and looking at the various NerdQAxe forums to see what everybody is able to push their devices to and try to set these limits. These are safety guards, safety measurements, safety measures in place to help you protect your device. You're playing around with those safety measures. You're taking off those guardrails or extending them, and you could wind up damaging your device. So this is a huge risk on my part. I want you to understand that if you do this, we are not liable. Mr. V777 and myself and RetroMike are not liable. This is all under your own. So this is where I need to study what the device is doing, where it's sitting at, what the limits are, the limitations are, where the temps are, and kind of fine tune this. But there's some other steps that we need to do. One is to, obviously, we need to change directory, right? So we downloaded it. So now we need to change directory. And what I'm going to do here is some trickery. And RetroMike's a lot faster than I am. But cd space Bitaxe dash hash rate dash benchmark. And now we're in that directory. But we need to make sure Python is installed. Now, right now Python is not. So I'm just going to type in Python. And what's going to happen is Windows Store is going to pop up. And I'm just going to click get and make sure that this is installed for this particular computer. And then we need to set some environmental variables, right? Or create and activate a virtual environment. Again, this is all in the GitHub that will be linked down in the description. Once Python is installed, the command that we're going to run here is this guy right here, python-m. Ooh, that was loud. Sorry if that was in your ear. That was in my ear too. But -m, virtual environment. So let's see if it works. Hit enter. Because Python's installed now. Let's see if it actually takes. Boom, it is. Okay. Now we need to install some dependencies. Let's make sure that everything... I don't think I need to run this command. I think that's Linux. Yeah, that's Linux. Source is not recognized as a commandlet. Wifey's coughing in the background. All right, then pip install our requirements, txt. It's installing. All right. To update, run. And then here's the command to run it. But I believe we're good. New release of pip is available. Okay, cool. Let's update. So let's see what happens if we run that command. -m pip install. Okay, so let's run that command real quick. All right, I just copied and ran that command. So we're successfully updated. And now we could run, I believe we can run our utility. Let me make sure real quick. So yeah, so here's the source file. We have that source file opened up right here. We can make some adjustments and save. And then when we run it, right, to run the actual benchmark, it's going to be a command similar to this right here. So Python Bitaxe _ hash rate _ benchmark.py for Python. And you can see that's this file right here that we're editing. And then the IP address. But again, we need to make sure inside this file that we have all our variables and environmental conditions and max clock and max voltage and all that stuff set inside this file before we go willy-nilly plugging stuff in. Just a heads up. So let me make sure, double check all this real quick, and then I'll let you guys know what the final results are. But we already have the stock numbers. Let's see what we can push this thing to on the current configuration. All right, so after the benchmark, we got some pretty decent results. You can see right now we're sitting around 6.1 terahash. However, as it gets hotter in the day, it's going to level at like 5.6, 5.7 terahash. We're doing 16.6 or 16 joules per terahash. Not bad whatsoever. Some rejected shares, so a little bit of adjustment can be done. But the ASIC chip temperature jumped from 55 to 60. The VRM temperatures jumped up to almost 63 degrees Celsius. Still good, and again, because I have a Noctua fan on the back, it's keeping the backside nice and cool. Right now, our wattage is sitting around 98 watts. I did maximize and limit the power draw, but let me just go over some of the key differences that I made. And by the way, I did put this all on a GitHub, so giving credit to the gentleman before that basically developed this Bitaxe benchmark, but just adjusting it to fit the NerdQAxe, right? Input voltage, a number of different variables. Most importantly is the benchmark rate. So I'm going to have link not only to the GitHub repo that I built just for the NerdQAxe or the NerdQAxe, but also a Reddit post where I talk about it, where you can go and comment not only on this video down below, but down on that Reddit post. But the first things first is, after some testing, I wanted to extend the benchmark time, because the NerdQAxe takes a little bit of time to ramp up. I didn't want it to, because it was averaging out the hash rate, but it was averaging out the 200 gigahash, the 700 gigahash, the 800 gigahash into the overall, or factoring that into the overall benchmark result. So I wanted to extend the benchmark, give it the best time. The max temp voltage I set at 68. Some people have that at 66. You can adjust that accordingly if you like to. Max voltage. This was, I believe, 1400, and I didn't like that. So I'm playing a little bit safe here. Because remember, some of the Bitaxes, especially with the 1368 chip, require more voltage to hit higher targets. And then the max allowed frequency, I put 750, but I wouldn't go above where I'm at right now, 680, 700. I think that's about it. Unless you really did some awesome mods to the cooling. And then VRM temperatures, 85, right? It was at 86. I dropped it down to 85. Minimum input voltage, 11.4 volts or 11,400. And then max input voltage, I put 12.1 or 12,100. And then power, again, I did 100. Now, the power supply I have is 120. But you should never push your power supply that hard. Just FYI. And then I just set, the other parameters. For example, the minimum allowed voltage, core voltage, right? Just like we did some adjustments up here for the max allowed voltage. 1120. The reason I did 1120 is because when I did the benchmark, what was happening is that when it would do 1000, like we can do with the Bitaxe, it would default to 1200. And I think 1200 is the max. Like, we don't want to push this thing too hard. So trying to do 1000 wouldn't work. I just went to the settings section of the miner, right? And basically saw that the minimum was 1120. And again, when you go below that, it's going to default to 1200 or 1.2 volts. So I just did that, left it there. Minimum allowed frequency, again, went to the settings section and saw what the lowest one is, 500. I'm sure you could do 480. I did 480, I did 470, I did 460. It did drop the thermals on everything quite drastically, but then you're sacrificing hash rate. And if you play around with that, I'm pretty sure you can make your thing really, really efficient. Other parameters that I adjusted is primarily to do the default, right? So the default voltage, default frequency, in case something goes wrong inside the benchmark, is 600 on the core and 1150 on the voltage. So I just updated that instead of 500, and I think 1150 was the default for both, so it doesn't matter. So I just adjusted from 500 to 600. Same thing here, just setting that parameter. And then the sleep time. I didn't mess, by the way, with ASIC count or small core count. I believe there's a couple of different areas where you can put that in for default settings, because that's what's used to calculate the benchmark result. And I know some people can play around with that and understand, how that works. I didn't. Oh, here we go. So sleep time. Applying new settings and waiting 300 seconds for system stabilization. So in between benchmarks, I wanted to allow a few minutes for the NerdQAxe to level off before it started to record those benchmark results. Again, because if you have the 200, the 300, the 500, the 700 gigahash in your overall results, you're going to have a lower performance. And then it's going to say it's out of range, and then it's going to decrease the core clock and then increase the voltage. So I wanted to allow more time for it to find it. And you can see it in the benchmark. It's still having a little bit of trouble. You can see my best result right here at the top. So 680 on the core. It's saying average hash rate of 5 terahash. Average temperature is 60 degrees, 19.45 joules per terahash. And then the VRM temperature is 63. But we're obviously getting much better than that. Because, again, the benchmark on this thing is focusing, I believe, the missing piece here is the chip count, the ASIC chip count, and the core count. Let's see here. Small core count. That's how that expected hash rate is calculated. Small core count times ASIC count, divide by 1000, calculate expected hash rate based on frequency. And you can do the math on that and figure that out. And there is an area for you to put in the small core count right here, which you can see is 0, and ASIC count, which is 0. I didn't mess with that. I just extended the limits so that way it could support the NerdQAxe, and then I extended the benchmark time frame. And then this is the result that we got. I saved it and then I uploaded it to the GitHub repo, giving thanks to the gentleman that came before us. So make sure you pay your respects. But it's basically the same thing, just with extended limits under my GitHub profile. That's all it is. And again, on Reddit, sharing this, I'm sure I'm gonna get some flack from some people. There's some very knowledgeable people in the Bitaxe, NerdQAxe arena that I will be more than happy to get schooled on, so to speak. Okay. So let me know what your thoughts are. We were able to push this thing up to basically 6 terahash, 6.1 during the evening, 5.8, 5.7 during the day when it's really, really hot, making it a little bit more efficient than stock. But of course, with better cooling, better mods, you could probably get a little bit extra performance. But tell me what you think of the benchmark. You could go in there and again extend the limits even further. If you really wanted to, you could push this thing a lot further, like, max allowed voltage, maybe 1250. I don't even think it gets that high. I didn't see any time where we got near, we could hit 1200, but I don't think we can go above 1250. At least I wasn't able to see it. Yeah, most of these are 1170 is the highest that I got here. But I did see on one benchmark result last night that I had to restart, we did hit 1200 because remember I told you, this one right here. I told you that if you set the minimum, the voltage at 1000, it will default to 1200. So it is possible. I wouldn't run it long term like that, but maybe you can do something better because you won the Silicon Lottery or your device is just that much cooler or you're in the snow. I don't know. Play around with it. Be careful. Do this at your own risk, understanding that you could damage your unit. I did some safe parameters. I still put a disclaimer on my GitHub, but I just put in some safe parameters and extended the limits, not only for the input voltage and max input voltage, but also for safety as far as, the time frame of the benchmark and for safety. But that's going to do it for today's video. Let me know what your thoughts are down in the comment section below or on the Reddit post, link down in the description. Do me a favor, hit that like button on the way out, get subscribed, hit notification bell to stay up to date, as well as check out additional links in the description that will support the channel and what we do here. And again, just to show you this is stock configuration, right? 600, 1150. This is stock hash rate, 4.7 terahash, which is advertised, 4.8. But then afterwards, here we are. We're getting 6.2, 6.1. Got another one here. We dropped below 6 at 5.9. And then I got another one here at 5.6 at the lowest during the peak heat of the day. So, all right. You all take care. I'll catch you next one.